Hey guys, welcome back. Today we're going to continue building out our first boss. We will begin to develop a library of tasks and services needed for our boss AI. In this video, we will start with a simple task to find the closest player. A lot of you have told me that you're really interested in converting BPs to C++, and so we will first implement our task in BP, and then I will show you how to convert the BP to C++ along with some tips and tricks to make that easier. So let's start out by getting this set up. Over here on the Let's Make an MMO page, there's a new project here, 44.2. So I've downloaded that, and I have extracted the zip file. Then we're going to need the latest copy of the OWS plugin. So I've grabbed that from here, and I've gone into plugins, deleted the old OWS plugin, and replaced it. You're going to want to do that first so that this next step can find it. We then go to our Open World Starter Project U project, and we will switch Unreal Engine version. You're choosing 4.26 and hitting OK, and that's going to generate you this solution file. We're going to open that up right here, and I just went in and opened up this character, so I had a C++ file open. We're going to add some more code today, and I went and ran that. The reason I did this ahead of time is it took like 10 minutes to compile the shaders and compile everything and get it all running. So now we have the project here. This is what you should get when you have it open up. And it's kind of where we left off last time. I actually had gone in and done some improvements to the map, added some more lighting and some other stuff. So it's a little bit different than where we left off last time, but that will be in that project file that I told you about. So the first thing we're going to want to do is we're going to want to change play standalone to play as client. We're just going to hit play and make sure it works. Okay, cool. So it's all working the way it was. Okay, so we need to start doing a few things. The first thing we want to do is that it's going to be annoying for testing this to have to keep climbing up those stairs every time. So we're going to come here, I'm going to drop an empty actor, go over to location, copy, go to our content browser, MMO, BP, and then underscore main. We're going to find our third-person game mode, and over in the defaults here, class defaults if you don't have it open, debug start location, I'm going to hit paste, and I'm going to hit compile, save, and we're going to try it again, and we're going to come back and delete that empty actor, and hopefully that will put us there. There we go, perfect. So we've got this guy here. I think he was just a dropped. Yeah, we just dropped him on the thing here to look cool. So I'm just actually going to dump that. We don't need it because we're going to start building out our boss AI. So I'm going to go here and I'm going to create a folder, boss AI, and we're going to create a new BP. We are going to inherit from, if you remember, we have our base character, and we're going to just call this boss AI. And we'll come here to mesh. We will choose Rampage. I think it was Elemental. Yeah, Rampage Elemental. And I think normally we drop him 90, negative 90, and we spin him negative 90. Yep, he faces the arrow. Usually I come down here and make sure the feet look good. I think they're pretty close. We can adjust later if it's wrong. And then we're back on the mesh. We're going to need to choose his anim blueprint. There we go. Okay. I think that's all we need to do here. So we're also going to need a boss AI controller. So we're going to come here. Okay, it's under blueprint. AI controller. I have an OWS AI controller. That's interesting. Yeah, let's use that one. So I think it just has a few things I've added to make things easier to work with. And we'll call this boss AI controller. we'll go to our event graph, and we're really just going to want to run a behavior tree, which we're now going to create. This is similar to the AI thing we did for the mob before. We're just getting the basics set up. We're now going to go to behavior tree, and I think I called it boss BT. Okay. And in that behavior tree, we're just going to set up a simple selector. And we'll have this go over to another selector. It's going to have a Blackboard condition. It's going to be a decorator Blackboard condition. And then we're going to, from that, do a sequence. And we will rotate to face the Blackboard entry. And then we'll just wait. Let's go with a second. Okay, so over here we're going to create a task that finds the closest player, but we haven't done that yet. And then we also need to go to our Blackboard, and let's create a Blackboard asset. So we will go here, Artificial Intelligence, Blackboard, boss, BB. It's going to manage our state. And we need to create a current target. So we're going to add a new key, current target. Oh, that wasn't what I wanted. I wanted new key, object, current target. Okay. So that looks good, and then we'll come back to our behavior tree, and we'll set the Blackboard to that one. Oh, wait. Proxy Blackboard. Ah! No, I don't want to actually edit that one. Okay, boss BT. Character proxy Blackboard. Why did it pick that? Hold on. Clear that. And unfortunately, it has picked the wrong Blackboard. So we got to go here and select the right one. Okay, cool. So now they're connected, and we can switch back and forth between these two, and it goes between boss BT and boss BB. Okay, cool. So we got that. We can come back to our AI controller, and we can choose the boss behavior tree. And I guess at this point, we just want to make sure that it's running. So we'll kind of sit this here and press play. We should really just see, oh, we haven't dropped the new boss AI in the world. Oh, and he's way too small. We want him bigger. Let's go over here. I don't remember what size I did. Let's see what 3 looks like. Okay, it probably seems about like what we're shooting for. We'll kind of get it somewhat centered here. To keep things simple, I don't think we're going to have him move. He's just going to rotate and do stuff to keep things simple. So let's open back up our behavior tree. Just hold it off to the side. This is always one of the things I highly recommend for UE4 is double monitor. I actually have 3 of them hooked up right now. We just want to see that this is running. Now I'm going to hit I'm going to hit Shift F1 to get my cursor back. Then I'm going to go up here. Can't find any matching actors. Okay, so this is why we did this test. We did miss something. So we've got this behavior tree. Run behavior tree, and we picked that. Ah, you know what? We did not assign the AI controller to the boss AI. So if we come back to the boss AI and go to these details, sometimes it's just easier to search here. Let's try, I think it's not AI controller, I think it's control. I'm on the mesh. Gotta make sure we're on the top one here. So if I start typing controller, yeah, AI controller class, it picked AI controller. We want boss AI controller. So we never connected those two, and that's why it did not run our behavior tree. So let's hit play again. Okay, cool. So it is activating it here. It lit up yellow. It's just not running anything, and it's because of this right here. We didn't finish it, so we're gonna hit stop. We're gonna go to our Blackboard condition, and we have to say is set current target, right? Does the boss have a target? And then rotate to face. We never set that. Actor. Why isn't it letting us pick current target? So I think the issue is there. Normally both of them are in the list, like this one here. A little confused why it's not. Let's take a look. Huh. It almost seems like it's just some kind of temporary caching issue. Anyway, current target is not going to be set until we build this task. So we will come back and deal with it then. So the next thing we want to do is start working on our task. So I'm going to go here, minimize this, and I'm going to create a folder for services and another folder for tasks. And then in tasks, we are going to create a task. So we're going to have a blueprint. I think it's BT task. Yeah, BT task node is the one we're interested in. Yeah, so we have to use the blueprint base one here for our blueprint one. And so we're going to click on this, and we're going to do BT task blueprint base. Looks good. Okay, so I don't think there's anything in here. We want to use execute, receive, execute AI. So we grab that. This is what's going to get called. And we're going to need some variables here. So we're going to need a variable called current closest target. And we're going to make that of type player character. Okay. And then we're going to make another variable for current closest target distance, because we'll be trying to find the closest target. We're going to set that to a float. And then, as always, we need a Blackboard key selector. So we're going to do current target BB, and this is going to be Blackboard key selector. And that one needs to be public. Okay, so we're going to use our regular algorithm that we use a lot, which is to loop through something and then keep finding something that's closer. And if it's closer, we set the new current one to that closer one. If it's not, we move on to the next one. So to do that, you always want to start out by setting whatever your closest one is to some huge number that's larger than can actually that's probably a bit larger than what I needed to go, but something that is large. It's going to round it, whatever. That's floats. And then we're going to do get all actors of class. And we're only interested in player character. So that's going to get us an array. So we're going to do a for each loop. We do not need to break because we have to do an exhaustive search. We won't magically find one and go, okay, we're done. We don't have to keep searching, so we're not going to do a break. And then what we're going to want to do is from this actor, we're going to do get distance to. And we're interested in this controlled pawn. So it's going to send in the boss AI pawn. Here's to get the controller, here's to get the pawn. So we're going to say what's the distance between the player we found and the pawn, and the boss pawn. So then we're going to ask the question, is it less than this get closest target distance? Now, on the first one, it always has to be yes, right? Because it has to be less distance than this huge number. So the first row it finds is always going to be the closest one. That makes sure that as long as there's at least one row found, we're going to end up with something. So then we say, okay, if you're closer than the last one or closer than the default, then we want to set the current closest target equal to that player we found. In addition to that, we also need to set the current closest target distance equal to whatever that new distance was, right? So this is basically an algorithm that keeps looking for one closer. Is the next one closer? Is the next one closer? Is the next one closer? And then when we get to the end, out of completed, after we've looped through all of them, we know that whatever is in current closest target, right here, is the closest one. So we will do, let's see, we already have it, so we're returning it. So there is a little bit of a thing we have to deal with here, is that there's the chance it didn't find one, okay? So the way we do that is we say not equal to empty, and that's kind of the same as in C++ of doing a not null. And so that's how we're going to check, did it actually find one? Because maybe there was no player, right? Maybe there was no player. Maybe the boss spawned in early before the player did, and the boss was in the world by itself, and we don't want it to air out. And so what we want to do is, if there wasn't one, we're just going to finish, execute, and the success is going to be empty, right? No success. Otherwise, we want to grab this current target BB, and we want to say set Blackboard value as object. And then we'll also copy this finish execute, but this time we're going to check, yes, it was successful, we did find one. And that just decides how it moves through this behavior tree task because of it being a selector. And the value that we want to set is this current closest target, right? So we're sending that out. We're saying, yep, throw that in the Blackboard. We found it. So I think we're good here. So let's go back to our behavior tree. And under tasks, we're now going to see this, wait, task. Oh, we didn't rename it. Let's fix that. Let's call it find closest target. So now if we come back to our behavior tree, we should have find closest target. And we have to set the target here, current target. See if this one has decided to fix itself yet. It hasn't. Let's close that behavior tree and reopen it. It's interesting. Where did the face PP self-target? The current target is sitting right here. Okay, well, the first thing we want to do is make sure that it can find it. So again, we're going to open this up. We're going to hit play. Okay, it found it. See, and if you noticed, it was looking for a little while before the player spawned in, if you watch that closely. And so now it's finding it, but of course it can't rotate to face because it's not finding us. So we got to try to figure out what's going on with that. Let's see. I already verified that it's using the right boss BB Blackboard. It has self factor and current target. Their settings are the same, so it's not something to do with the setting. It feels like it's a blueprint compilation issue. Let's close all these and see if that does anything. It did not. Okay, so when in doubt, let's hit save, and we're going to just restart the whole project. I do not want to save that one. I actually edited that by mistake. If you remember, it switched to it, and I didn't see that it was there, so I do not want to save that. Let's give it a. I'm going to try again. I don't see any reason why it should have a problem with that. It should be fine there. There's nothing odd going on there. So it feels like it's just some kind of temporary compilation or something I did when I accidentally selected that character proxy. It's like it's not seeing it. Current target's right here. It's on the Blackboard. Okay. Let's do a comparison here real quick. I've got the other one open on another screen. It's the one that's working. Yes, I'm just going to double check if anything is slightly different. I didn't choose a parent. Current target, there's no spelling issues. Let's go to the behavior tree. So in the behavior tree, I go to it. I have both options available. Blackboard asset is boss BB. They're both the same. Both of these show exactly the same here. Current target is set here. Find closest target is current target here. There's nothing different about that. Very odd. I expected recompiling was going to fix that. That's not a task we made. Okay, let's try deleting it. So sometimes you gotta remove a node. So there's a rotate to face BB entry. Still no. Okay. This one gave us both. You know, one thing that I did find interesting is that over here on the Blackboard, it was just object, but both of them are. Yeah, that's our, so you can't make a more specific. Oh, actually, you can pick a base class. Ah, okay, hold on. It might be because the base class is not an actor. So I'm going to take a look at that over here. If I go to the key type, it is. Got it. That's our issue. So we had to open up this base character and do our base character. My guess is that that other rotate has a thing that says, hey, it can't just be an actor. It has to be an actor. I mean, sorry, it can't just be an object. It has to be an actor or further down the chain. So let's see if that makes a difference. It did. Ah, I had totally forgotten that you have to open that up to get the base class to set it. So we're setting it to our base character, which is an actor, and then a pawn, and then a character, and then OWS character with abilities, and then our base character. So we now have that. So now, if we save this and we play it, he should rotate to face us. And he does. Basically with his his 1 second delay between his rotate that we have on that wait. Okay, cool. So we got that part working. It's working in that. So now it is time to convert that to C++. Okay, so what we want to do is we want to come over to here and do new C++ class and show all classes. And we're interested in BT task Blackboard base. So that gives us the task node, but it also gives us the ability to use the Blackboard, which we need to do. So we're going to pick that and hit next. We want to make sure that it doesn't go into the plugin, it goes into our project. And we are going to call it BT task. And I know I called the other one get closest target, but I feel like get closest player makes more sense. So we're going to do get closest player, and we are going to create the class. It's going to create 2 files for us in C++, and then we can start working on it. While it's doing that, I'll show you that one of the things that I keep open is I keep open the GitHub here, Epic Games Unreal Engine. To access this, you will need a GitHub linked Unreal Engine account, which you can do from your Unreal Engine account setup. You can go in there and link it to your GitHub account, and then you'll be able to get in here. And what I do, let's see here, BT task node H, I think it was. Yeah. So one of the things that's terrible is the search is horrific. You can do a little bit by filtering it, but that's not even going to fix much. So you end up having to scroll through a lot of pages to find the one you're actually interested. And I'm interested in BT task node. So it's always good to read the notes at the top here. This one's actually really important. We're going to kind of ignore it for today, but we'll fix it in the next one. It's kind of a complex issue. So it tells us tasks are leaf nodes of behavior tree which perform actual actions. That's great. Because some of them can be instanced for specific AI, following virtual functions are not marked as const. Okay, so we look at that. This one's real important though. If your node is not being instanced, which is the default behavior, do not change any properties of the object within those functions. That's a bummer because we are changing some properties. So what it's basically saying here is that the behavior tree task node, for performance reasons, it's not making a copy of it for each one of your AI. They're all sharing the same task. And you're like, whoa, that's crazy. They're sharing the same task. You know, that means that when they're sitting there searching to find which one's the closest, if 2 are doing it at the same time, they're sharing that same closest float and closest target. It's going to be a nightmare. It's going to be horrible. So there is a way to fix that, which they tell you. You have template nodes are shared across all behavior tree components using the same tree asset and must store their runtime properties in provided node memory block. This is pretty complicated. We're going to cover it. Later. So we're going to pretend that we can put memory right inside this and manage it, and we'll fix it later. So that's an important note. Always good to read these notes here. We're going to come down here and kind of look through at what we're interested in. So starts this task should return succeed, failed, or in progress. Okay, so this execute task, that looks important to us. Let's see if there's anything else here. Okay, we've got some protected ones. We're just looking at what's here. We don't need to tick the task. If we needed something ticking, we could do that. So okay, cool. So we kind of seen what we've got there. We should now be able to come over here, and we should be able to hit reload. We'll have to stop debugging. And okay, it did the public-private thing, whereas these other ones aren't split. Whatever, we'll fix that later. Yeah, it's fine. That's actually what I usually do. That's what Epic does. They split them between the two. So we've got our H file in public and our private in here. So we're going to open both of those up. And we're going to look at what we've got here. So we've got a generated body, but this is actually a U class. So I'm going to change it to generated U class body. And we're inheriting from UB task. That looks good. This is the name of our class. and we need to add some things. So we're going to come down. It's automatically by default public, but I like to throw it in here so we can see. And we're going to create a U property. Remember how we had to create those different properties on the blueprint task? So now we're going to basically have to do the same thing here. So we're going to do blueprint read write. We're going to do edit anywhere, and we're going to do F Blackboard key selector target player, and we're going to run into our first C++ issue. Actually, we may not. Yeah, we're not going to. So it actually, so I'll hit compile just to see here. So what sometimes happens is that you use a type and the type isn't. Oh, let's take a look. So first thing here, ignore the error list, right? Ignore the error list. It doesn't matter. Output's what you're interested in. And you always start from top to bottom because bottom errors that are lower down may actually be caused by ones that are higher up. So why fix one that's not actually an error? Because fixing the one above it's going to fix it. So you start at the top, you read down, it's creating it, and it actually is only a linker error. So there's nothing wrong with the code compiling. It's a linker error, and it's that it's looking for certain things. So it's looking for certain code over in the CPP that we did not define. So we're going to need a few. We're going to need a few things just to start. So we use this U class body here, and so we're going to have to define our own constructor. It's not going to do it for us. So we're going to copy this name here, and we're going to add this constructor. And we're going to do const f object initializer ampersand. It's a reference to the object initializer, and then we're going to make sure that we call the base class and send it to it. That's important. So super object initializer says, hey, we inherited from this UBT task Blackboard base. Call that constructor, and that one probably calls its constructor, and that one calls its constructor. It goes all the way up the chain. We don't mess anything up. So we need to give our node a name. So we're going to call it get closest player. I'm sure this is just so it can show up nicely in the thing. And oh, we are okay. So for now, we're actually going to set create node instance equals true. So that's actually going to mean it's going to make a copy of for us out of each one. That's not the default, but that's how we're getting around that issue of having our own memory. Otherwise, some of this other memory that we add. So let's come back here. So we're going to then add protected. So the difference between protected and private is that private cannot be accessed by inherited classes that inherit from this class. Protected isn't public. You can't access it outside this class, but you can access it within things that inherit from this one. So we're going to do that. U property transient. And we're going to do AI controller, AI owner. So this one is going to store a cache to the AI controller, and then this next one is going to store a cached actor to the actor owner. Those are things that over in the blueprint they did for us, but we now have to do them manually ourselves. Just going to copy these nice notes from the other project here, so I don't have to type those out. I actually have to be a little careful on the time in this video because I'm recording to a drive that is almost empty. So hopefully we do not hit that. Okay, let's come back here. We now have this constructor. Let's see if that makes it happy enough to compile. Okay, it is not happy. Now it's saying missing pointer in expected type. So if we double click on that, it'll take us to it. And that was actually supposed to be an A actor pointer. but I typed it poorly when copying from the other screen. So if you double click on it, it takes you to the error. Remember, don't use this list. Totally ignore this. I don't know why it goes to it. Always use output. See if it starts compiling. No. That's mad about something else. And that's often what happens. It keeps going further. So now, okay, so it's mad about on gameplay task activated. That is interesting. So, unresolved external symbol, I gameplay task owner interface. Oh, well that's kind of odd. Why did it let us do it? Yeah, so this error has nothing to do. This error has nothing to do with this. Huh. That's funny that it was able to compile it the first time to begin with. You guys probably will run into this error earlier on. So it's telling us, it's giving us a clue. No, it actually is complaining about this file. Okay, hold on. Maybe it's not maybe it's not an issue. Let's see what we might be missing. We didn't say that we were going to gameplay task owner interface. Oh, got it. So, okay, so here's what happens here. There's an interface on this. Let's see if we could have found this from, so we would have had to go backwards, probably to this UBT node. And let's try that. Wait, actually, that was the one we were in. That was the one we were in. I was going to try to show you the code. That was the one we were just in. Oh, that's task node. So what's happening is that there's an interface at a previous level. If we went through the whole chain of them, we'd find that somewhere here they're inheriting from an interface. And because of that, an interface is a promise. We promise to inherit. We promise to implement this thing, and we didn't do it. We didn't follow the promise. So we have to follow the promise. And the promise that we said we would implement was, I'm just going to copy this to make it faster. I'll talk about it. This one. So we promised that we would implement set owner. And what this is doing for us is it's giving us that actor owner that it's sending, and then that's allowing us to get the AI controller and then get the AI owner. So actually that actor owner is not, let's go fix that. Oh, I did, cached AI controller. No, actually that's wrong. That is right, it's the actor owner. I'm just going to put this in parentheses. It's the AI. Don't think it's the pawn. Okay, so we promised that we would implement this set owner. We didn't, and this thing got mad. Let's see if that fixes it. I believe that's what it was mad about. Some of the fun things you have to deal with C++. Okay, so now it's telling us, hey, you did the set owner here, but you never told us in the H file you were going to do that. And that's exactly right. So we have to come here, and we have to put virtual void set owner actor override. So we're saying, hey, we're overriding it. There's a base one somewhere in the base class in the interface. We're overriding it. Now it should be happy. Okay, it's probably unhappy about something else. Let's take a look. Whoa. Okay, so now it's saying use of undefined type AI controller. Awesome. So what we have to do, AI controller, no, that's actually not an undefined type. Oh, wow. We're getting into some fun stuff here. just basically because I'm adding lines in a different order than I added them to begin with, so I never ran into this. See reference to class template instantiation, da 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 da, okay, whatever. It's instantiated with incomplete types. Okay, so what we're gonna have to do, we're kind of trying to build it halfway, and it's mad about it. So what we're gonna have to do is we're gonna have to copy in the missing code so that it's not unhappy. So some of this code we're not gonna use today, we're gonna use later. But I'm copying in these ones we're overriding. So we're going to override that execute task. That's important. That's where our code's going to go. This describe runtime values is for debugging. We're going to talk about that later. And then we've got this get static description and this get instance memory size, which is actually going to play with this. I'm going to paste it for now. We'll deal with it later. Remember I said you have to have task-specific memory. So that's where that's going to be. And then we're going to go over to our CPP file, and we're going to add some of this missing stuff. So these things here that I'm going to paste at the bottom, they're kind of just placeholder code to make it happy. Our get instance memory size, and that was this here. And then this getting this description, it's going to say get closest player. You can also have it show data. So this is how you can make in the Blueprint editor. We'll talk about it more later. You can have nice data show. Same with describing runtime values. I just say, hey, just call the super. That's good enough. But the one we're interested in right now, I'm going to copy the code and we'll go through it line by line, is this execute task. Okay, so this is the point where we're going to need to go look at our blueprint and we're going to need to go through it line by line. So I'm going to get this running, but we're going to need to do a couple things first here. So you notice it's got some stuff underlined that it's not happy about. And so this is one of them here. And so we know, and actually this is interesting. I want to see what it does on the show potential fixes. That's actually pretty good. So that's new that they've done that. That's kind of cool. I actually usually do the double quotes, but it actually went and found it for us. That's one of our classes, and it added it automatically. That's kind of cool. Okay, so we have another one that it's unhappy about is this gameplay statics. So here's what I do is when I have the piece of code, I go over to Google and I type UE4 C++ gameplay statics. It finds it for me, and it has what to copy, the include, right? So this is how I get my includes, and I go here and get this, and it was also mad about AI controller. So we go back here and we do AI controller. So if it's an actor, it starts with A. If it's not, it starts with U, if it's still a class. So U is for U object, A is for actor. So sometimes you have to switch those around. We're going to copy that one, include. And then we need two other ones that it's unhappy about. And that is this Blackboard component. So we're going to go here, and I don't know which one it is. So I'm just going to type Blackboard and component and hope it can figure it out. It's U Blackboard component. And so we're going to grab that one. So we're grabbing the pieces we need. And then that might make it happy. I had this line here that I was using, but that one actually didn't work very well. Let's see if that makes it happy. I want to get back into UE4 so that we can get to the blueprint and we can go through how we move one node at a time. But unfortunately, that means I have to get it back running. Okay, still mad, but it is in the linker that it's mad. So it is unhappy that already defined second definition ignored. Okay. Okay, it's starting to now throw stuff. Yeah, it's starting to throw stuff that it shouldn't be throwing. You see there, I shouldn't have listened to it. See it grab .cpp. That was actually .h. I didn't watch that close enough when it added it. So I guess don't go over it and have it find its own solution because it doesn't always choose the right one. That's funny. Okay, let's see what it's mad about now. On gameplay task activated. Unresolved symbol on gameplay task activated. Okay, let's see what we're missing here. We got generated uClass body. We've got uClass here. T-task get closest player. We inherited from Blackboard base. We've got all those. We've got this U property protected. Only thing different about my code, I guess, is I didn't have that. Otherwise, that code is identical. And that code. Did I spell it wrong? Is that what happened? And I copied in code that was spelled wrong? Closest player. That would be a dumb mistake to make. Oh, wait. No, I don't think I did. I think that's the same. Still mad about this on gameplay task activated, but what is interesting is that I do not have that in my code, and I'm not having any issues. Let's search for a task owner interface. Why is it not unhappy? Why is it unhappy? Or did not have any of those issues in the other one. The code is now line for line identical. Did I? Okay. Let's just double check the order of some of these. I don't think it needs this, but I'm going to add it. It would be an H file. It's not going to. H files can't fix a. It's basically saying that CPPs don't exist, right? That it's looking for. It is saying it's in this task. So basically what that's telling you in the object linker, it's saying you're telling us that you're going to provide something in your CPP. Your H file is saying, go look for this, go find it. And you didn't actually implement it in your CPP file. That's what they're telling us. This can happen because sometimes you don't have the right namespace, right? If you mix up a namespace, it won't find it because it's only searching in the same namespace. It can happen if you forgot to implement a certain function. But I am not seeing anything. So I typoed one of these early things that I was typing. Do not see anything different. Just in case. Just gonna do a full replace. I don't think this is it. We'll give it a try. The other thing we may have to take a look at, sometimes you have to dump the temporary files, but I shouldn't have to do that because I did that before. No, man, it's gonna be a fun one. Okay, I'm gonna actually stop recording, and I'm gonna take a look because I was not expecting this error to come up because it didn't happen in the other one. So I will be back. Okay, that was actually a really simple one. Let me show you the process that I used to find it. So it was complaining about, get it? Now I can't get the error. So let me go back here. So it was complaining about this iGameplay task owner interface. So what I did is I went and used what I said we do here, and I went and put UE4 C++ iGameplay task owner interface, and I clicked on this. And I saw, look right here, it is used UBT node. So it's like, and then I saw what it was, the different things we were promising, and this was the promise it was unhappy about. Now I have no idea why my other project that's exactly the same version of UE4, exactly the same everything, runs fine without this. We'll probably figure that one out later. But we're going to make it happy, and we are going to implement this. So I clicked on this, and I copied this syntax here. Okay. I then went and pasted it here, and I added the word override. Okay. Then I went and copied it over to here, and I removed virtual. We don't do that here. And I removed override, and I added in front of it our namespace. Okay. There's nothing in it, but that was what we promised to implement, and because of that interface. Again, I still have no idea why I did not have to do that in the test project, and I did have to do it here. We'll probably figure that out later. But let's load it up. Let us continue with what we're doing here. I'm actually gonna blank out this data here. I just wanted to get this open, and then we're gonna go through moving the blueprint nodes one at a time and talk about how we find them. Okay, so the reason I wanted to get back here is that I want to be able to open up the task that we had, because we're going to try to convert this blueprint to C++. So I'm going to come back over here, and I'm actually going to dump everything in this so we can start fresh. Okay, so we're going to look at our blueprint. We're going to see what it's doing first. The first thing it's doing is setting our, well, first of all, the first thing it's doing is it's got this execute AI. So we have to figure out where is that. Well, that's the execute task, right? But it did not give us these two values. We had to get them set here in this set owner, and then they're going to be available to us. So the first thing we're going to have to deal with, and this makes this a little bit harder than converting other types of blueprints, is that we first have to deal with what's all this stuff here that this thing's doing for us. And it's getting us these controller and this pawn. So we need this pawn because we're using it. So what we have to do is we have to figure out how to do that. So what we have is we have the AI owner. Okay. So with the AI owner, that's a pointer, and we should be able to do get pawn because it's a controller. Perfect. So we now have the pawn. So let's assign that to a pawn pointer, and we'll call it controlled pawn. That's the wording that Epic uses. Okay, so we now have that. So we now have the controlled pawn, and that basically is equal to this. Well, that's great. We have that. But let's see. Yeah, okay, cool. So what we want to do, though, is we want to make sure, and we probably should have done this in the blueprint, but we didn't, is like, well, what if that controlled pawn was, for some reason, null, right? We didn't put a safety check, but we are going to put one here. So what we're going to do is we're going to say if not controlled pawn, then we want to return, and it's called EBT node result failed. Okay, so we're saying, hey, you didn't give us a controlled pawn, we cannot find you the closest player. So safety check in case the controlled pawn, because here's what could happen. The AI owner may not have a pawn. It's no requirement that they do. So it's a good safety check there. Then we're going to move to the next line blueprint, which is this set current closest target distance. So we're going to go over here, and we're going to find our... Actually, it's just temporary. We didn't need to... It didn't need to be on the object itself. We really only need it inside this task. So we're going to do float closest target distance equals, and a lot of nines. Okay, and then what we want to do is we want to have a current closest target, and it has to be our base character. But I'm actually going to go further and use this let's make an MMO character. So I'm going to say A for actor, LM, let's make a MMO character, and it's going to be a pointer. I wanted to talk about something here real quick though with this controlled pawn, actually, I forgot. Is that one of the cool things about these pointers is that they return true if they have a valid value, they return false if they don't. So by saying not controlled pawn, it's saying if you don't have a reference, run this code, otherwise continue. And we're going to call it current closest target. So that basically, and I did not put a semicolon at that last line. And this one here is taken care of by this line right here, right? So that header goes and finds us that, otherwise that would be unhappy. So that is basically equal to us defining this current closest target here. Here we just made it player character, but I'm making it a C++ class. That was a blueprint. Okay, so then we want to build a T array. So a T array is basically just an array, and you have to give it a type. We want to hold A actor pointers, and we'll call it found characters. So again, this is part of this get all actors of class in this for each loop and being able to loop through them. But again, it works a little different in C++. So what we're then going to do is run uGameplay statics. We're going to use the namespace operator, and we're going to do get all actors of class. Sometimes these can be fun to find. So a lot of times what I will do is I'll come here, UE4, C++, get all actors of class, and it tells me it's in uGameStatics. It gives me that include that we used, and it tells me what we have to send in. So we have to send in a world context object, we have to send in the actor class, and we have to send in a reference to a T-array actor pointer reference, which is why we created this, so we have something to send in. So the first one, it needs a world context. That is just get world. It's just one of the built-in things that we can do to get a context to the world. Then we're going to want to send in, and basically what we're saying here, this one's kind of interesting. It needs to know what to look for, okay? Because this get all actors class is going to look for a certain type. Well, they actually have this thing called static classes because in UE4 there's a copy. Every class gets instantiated. Every class that's a U object gets instantiated when you're running UE4, even if you're not using it. And that's called the, now I can't remember what it's called. It's so you can edit the values in Blueprint, but they have a name for it. Anyway, it slipped my mind. Maybe I'll remember it later. And basically, static class is just getting that. And then we're going to do found characters. Okay, so this is basically just going to fill, and I spelled this wrong. Okay, so it's going to fill this array with all actors of class in this world, which is our world, and it's going to look for these, let's make an MMO character as the base class or anything beyond it, which will be all our Blueprint classes because they all inherit from it. Then we are going to make a for loop, which is a little bit different. You do auto type found character. So what's happening here is it's saying, I'm not defining what the type of a found character is, just to get it from whatever you're searching. So found characters is a actor. So found character is going to be a actor. That's all it's doing. It's just so you don't have to type it. I could just put a actor pointer in place of auto. It's a new thing C++ lets you do. So then we're going to filter out the boss mob so it doesn't find itself. So we're going to say if found character equals equals. So in C++, 1 equals is the assignment operator, double equals is the compare operator. They're separate. So we want to compare. So we do 2 of them, controlled pawn. So what I'm saying here is if you're somehow found yourself, right? If the boss AI finds the boss, because it is a character of the class, so it is going to find it in this list. One of the things is going to be the boss. You don't want it to target itself. Then I'm going to say continue. And what continue means is it says don't continue in this loop, just go to the next one, right? So from this line, it jumps back up, finds the next one in the array, and then tries again. So it's not going to run this here. So then we're going to do distance to actor equals, I'm going to do found character. This is the, so if we have a reference, we can do dot. If we have a pointer, we have to do the pointer operator, which is the dash greater than. And we're going to do get actor location minus controlled pawn get actor location. And the reason we put the parentheses around this whole thing is that we then want to take that value and do size, which is just the way of doing the length of a vector. So these two, subtracting them, this is a vector, subtracting them gets a vector. So inside this parentheses is a vector, and then we can call dot size from that vector. So that will get us the distance to actor in here, and that is equal to doing this get distance to, right? That's what we just built. We grabbed the value out of the array, we did this get distance to. Okay, so after we do that, we're going to need to do another comparison. No, can't use capitals. And what we want to do is we want to say, is this distance to actor that we just found less than our closest target to distance, right? So this is this check right here, this less than, right? So this if here, that's what we're building. And then inside it, we're going to say closest target distance equals distance to actor. Okay. So we're saying that's this right here, right? That's that. And then in addition, we need to do this, which is set the current closest target. So we're going to go back here. We're going to do current closest target equals, we're going to have to do a cast because this found character was an A actor pointer, but this is a, let's make an MMO pointer, which is inherited from it, so the cast is going to succeed, it's not going to fail. And so that's going to take this found character, which is of type A actor pointer, and we're telling it, it's not doing anything, right? Cast doesn't actually do anything. It just tells it, it says, hey, you thought you had an A actor pointer. I know you actually have a looking for MMO, let's make an MMO character pointer. So I'm just telling you what you have, right? It's just you instructing the code that you know as the programmer know more than it knows. It doesn't actually do anything behind the scenes. We're just saying, hey, current closest target, it's actually this type. Even though you thought it was an A actor pointer, it's actually this type. And then that's going to find it. And so then at the end, outside of the for loop, we're going to again want to make sure that we're only setting the value if we found one. Okay, so we're going to say, hey, is that reference valid? And then if it is, we're going to find the AI owner. Okay, and the AI owner has the Blackboard component. So we're going to say, hey, give us the Blackboard component. And then that will let us use set value as object. Remember, it was an object type. And then this takes two parameters. And the parameters are target player dot selected key name. So if we come back over here, you'll see that this target player is F Blackboard key selector. And if we go over here and do UE4 C++, F Blackboard key selector, we will find that there is a selected key name that gives us an F name. Okay, and that is what this set value as object. Let's see if it shows it here with the IntelliSense. See, it needs the F key, const F name, key name, and then a U object. So the U object that we're going to send it is going to be this current closest target. And then if that's the case, then we want to return EBT node result, the namespace operator, succeeded. And if it didn't, then we're going to come up here and copy this failed. Nope, you didn't find one. We're going to put this here. Okay, so we've now converted that at the end was this, right? This check. See here, we either found it, we set it, and we succeeded, or we didn't, and we fell out of it and went to here. So I'm now going to recompile that. This works sometimes, but it's got a lot of issues, so I'm going to just exit it and recompile. And then what we're going to do is we're going to switch our behavior tree to use this new C++ task rather than the blueprint task and make sure they equal. I know that I typed something wrong. Potentially uninitialized local variable current closest target. Oh. It's mad about it being uninitialized. Interesting. Another error that I did not get. But it's a good one. It's a good one. So we're going to go here, current closest target. And up at the top here, we're initializing stuff. We're going to say set it equal to null. Wait. No, that was my bad. It was in the other code. We needed to set it to null to begin with. So one of the things that happens in C++ is that when you define a pointer to a memory variable, it leaves whatever trash is sitting in it. So it could be part of another program you previously ran. It could be, you know, anything. Anything that you've previously done on the computer could then be shoved into that location. So we're going to set this pointer to null, and it's going to be happy. Just a typo earlier. Always want to set those pointers to null to begin with. Cool. So we're going to come back here, and we're going to open up our behavior tree. And we've got this BT task find closest target. There's now, under tasks, there is find. Okay. Interesting. So it did not find our task. Find closest target. That's not the one. We should have one called find closest player, or get, oh, wait, get closest player. That's what happens when you do bad naming. Okay, it was here. I was just trying to do it with find. So what we'll do is we'll grab this to here instead. I hit alternate to disconnect that. I'm just going to throw it out here. And what we'd like to see working now is that it finds us and rotates the same as it did before, because our whole goal was to replicate in C++ the same thing we were doing. And look at that, it is not working. So we want to do, we want to come over here to our thing and let's see. Wait, we're running. Did I not save something? Let's go back to our boss AI and make sure that the proper AI controller is set. Boss AI controller looks good. Let me hit play again while this is open. There we go. Okay. So it's calling the get closest player, but it's never setting it. We forgot something, didn't we? So we got to click on this get closest player, and we got to tell it to set the current target. Now let's give it a try again. Oops. Just going to leave it open so we can watch it. Look at that. It now found us, and it's properly doing the rotate. Awesome. So what we did here now is we don't need this blueprint one anymore, because we have now created that blueprint task in C++. So we're going to stop here. In future episodes, we'll continue with this. We'll keep creating more tasks. We're going to need a task to be able to fire gameplay abilities, right? So this boss is going to have different attacks it does at us. We talked about some of those in the previous video. We're going to need a task that lets us pick a gameplay ability and have it, fire that at the current target, whether it's throw some kind of projectile or, I think we were going to have one where rocks and stuff were going to fall from the ceiling. There were going to be things where it knocked you back and threw you backwards off of it, and you had to climb back up the stairs. So there's a lot of different ones. So we're going to keep continuing to add those. We'll talk a bit more about some of this stuff that we didn't cover, such as the get static description, runtime values, and that get instanced memory, which we totally skipped over. We will come back to that and cover that. But for now, we got to figure it out. So until next time, see ya.